In a computer network, interfaces and cables are used to connect different devices together, such as computers, servers, printers, and routers. An interface is a physical connection point on a device, which allows it to be connected to another device using a cable. There are different types of interfaces and cables used in computer networks, depending on the type of device and the distance between them. What is Ethernet? Ethernet is a collection of network protocols and standards that define how data is transmitted over a wired network. It specifies the physical and data link layers of the OSI networking model and provides a set of rules for transmitting data between devices. Some of the key Ethernet standards include Ethernet IEEE 802.3, the original Ethernet standard that defines how data is transmitted over a shared medium using CCNA CD. Fast Ethernet IEEE 802.3U, a faster version of Ethernet that supports data transfer rates of up to 100 megabits per second. Gigabit Ethernet IEEE 802.3 AB, an even faster version of Ethernet that supports data transfer rates of up to 1 gigabit per second. 10 Gigabit Ethernet IEEE 802.3A, a high-speed Ethernet standard that supports data transfer rates of up to 10 gigabits per second. 100 Gigabit Ethernet. This standard supports data transfer rate of up to 100 gigabits per second. Why do we need network protocols or standards? Network protocols and standards are essential for ensuring that different devices can communicate with each other over a network. Without them, it would be difficult or even impossible for devices from different manufacturers to work together or for networks to function efficiently and reliably. Here are some key reasons why network protocols and standards are necessary. Interoperability. Network protocols and standards provide a common set of rules and guidelines that devices must follow to communicate with each other. This ensures that devices from different manufacturers can work together and that networks can be built with a mix of different components. Efficiency. Network protocols and standards are designed to minimize the amount of data that needs to be transmitted over a network and to make the most efficient use of available bandwidth. This helps to ensure that networks can operate at high speeds and that data can be transmitted quickly and reliably. Security. Network protocols and standards often include built-in security features, such as encryption and authentication, to protect against unauthorized access and data breaches. Reliability. By providing a consistent and predictable set of rules for communication, network protocols and standards help to ensure that networks are reliable and that data is transmitted accurately and without errors. Overall, network protocols and standards are a crucial component of modern networking and are essential for ensuring that networks are interoperable, efficient, secure, and reliable. How data transfer through Ethernet cables. Data transfer through Ethernet cables involves the transmission of bits and bytes of data over the physical connection provided by the Ethernet cable. A bit is the smallest unit of digital information and can have a value of either 0 or 1. In Ethernet communications, bits are transmitted over the physical medium of the Ethernet cable using electrical signals or light pulses. Bytes, on the other hand, are a collection of 8 bits and represent a unit of information that can be used to represent characters, numbers, or other types of data. Bytes are typically used to transmit data over Ethernet connections, and the number of bytes that can be transmitted in a given time period is known as the data transfer rate. Ethernet data transfer rates are typically measured in megabits per second (MBPs) or gigabits per second (GBPs) and represent the amount of data that can be transmitted over the Ethernet connection in 1 second. For example, a data transfer rate of 100 megabits per second means that up to 100 million bits of data can be transmitted over the Ethernet connection in 1 second. When data is transmitted over an Ethernet connection, it is typically broken down into smaller packets of data, each of which is transmitted separately over the Ethernet cable. The packets are transmitted using a set of rules and protocols that define how the data is transmitted, how errors are detected and corrected, and how the packets are assembled into the original data at the receiving end. Physical interfaces and cables play a major role in connecting the different devices and the network components throughout the network. The Ethernet physical cable can be copper cable, optical fiber cable. Twisted pair cable is a type of Ethernet cable that consists of pairs of insulated copper wires twisted together in a specific pattern. The twisting pattern helps to reduce electromagnetic interference and crosstalk between the wires, which can degrade the quality of the signal being transmitted. Twisted pair cables are widely used in Ethernet networks and can support data transfer rates of up to 10 gigabits per second. There are two main types of twisted pair cables: unshielded twisted pair (UTP) cables and shielded twisted pair (STP) cables. UTP cables are the most common type of twisted pair cable and are widely used in Ethernet networks. UTP cables consist of 4 pairs of twisted wires, with each pair color-coded to make it easy to identify. UTP cables are relatively inexpensive and easy to install, but they offer less protection against electromagnetic interference than shielded cables. Shielded twisted pair (STP) cables. STP cables have an additional layer of shielding around each pair of twisted wires, which helps to further reduce electromagnetic interference and crosstalk. STP cables are often used in high electromagnetic interference environments, such as industrial settings or areas with a lot of electrical interference. However, STP cables are more expensive than UTP cables and can be more difficult to install. Both UTP and STP cables are available in a variety of categories, such as Category 5, Category 6, and Category 7, which define the performance characteristics of the cable. Higher category cables generally support higher data transfer rates and better resistance to interference, but may also be more expensive than lower category cables. RJ45 connector. An RJ45 connector is a type of connector used with Ethernet cables to connect network devices, such as computers, routers, and switches, to a network. The RJ45 connector has 8 pins and is designed to connect with twisted pair Ethernet cables that use either the UTP or STP configuration. The connector is typically crimped onto the end of the cable using a special tool called a crimping tool. The pins inside the RJ45 connector are then aligned with the wires inside the cable and the connector is pushed onto the cable until it clicks into place. Once the RJ45 connector is attached to the Ethernet cable, it can be plugged into a network device such as a switch or a computer's Ethernet port. The connector is designed to make a secure, reliable connection that provides high-speed data transfer rates and low signal interference.